We're going to talk more about this over the next 2 weeks. But for now, I just want to give you an eyeball sketch of what in the world is going on. So, temperature, time. The one thing that we absolutely know is where we started. We start at T0, y equals 100. Okay. The only other thing we gave it was this differential equation. That was y prime is minus k y minus, let's put in the numbers. So this number here was 0.7. That number was 20. So think back to your first week of differential equation class. I've got a number. I know what temperature I'm at right this second. I can plug that in. I can plug K in. So what? I can get y prime. I can calculate this because I know the starting value of this. This at the start. So we can find what this is. How would I represent that, the y prime, on the graph? It's a slope, absolutely. This is a formula for slopes. So what do we do in the graph? We say, well, I know the slope. Only right here. I don't know it everywhere, but I know it right here. I can calculate it. And so I can follow that slope for a little while. I can take a little step delta t here. I can follow that slope. I'll find a change in y. Some of you have seen Euler's method maybe in other courses. And then I'm at a new point. Hey, I'm at a new t equals something else. Let's call it t1. And y equals y1. Oh, well, I can plug that in, get a new slope. And so I get a new slope. That's over here. And I follow that slope for a little bit. But that slope's going to be shallower because my temperature's lower, and I plug my numbers in, I get a lower number for the temperature difference, so I get a smaller slope. So it's going to be more shallow. And you can imagine stitching together these slope lines and eventually ending up approaching 20 degrees. So what's going on is not, it's actually just grade 9 straight line math slopes right now. The only thing is we have the interpretation of this differential equation being a big thing, but it's just a formula for slopes on this graph. And so we can predict where things are going to go because we know what, on each small interval, what the prediction will get us. If I start at 100 degrees at time 0, I can find the slope and predict that after 1 minute, the temperature is going to be around something else. And then I can use that prediction again. But you'll notice that's why we need this as a function. We are plugging in essentially, not random, but unpredictable y values into this thing. We don't know in advance what y's are going to be plugged in to get our slopes. That's being calculated as we go. So that's why it's so important in the MATLAB code that our differential equation be with this ampersand sign. Differential equation is a function of t and y. We desperately need that because we don't know in advance what t and y are going to be. So we work with that as we go through it.